So we got one more illustration. Let C1 and C2 be the center of circle this and this. So you got two circles C1 and C2 and their point of intersection is P and Q, and the area of the quadrilateral P C1 Q C2. So suppose this is the first circle, suppose this is second circle. So they are saying it is C1 C2, this is P, this is Q. Okay, so these guys are interested in finding area of this quadrilateral. Okay, just look at this. So how we will approach this kind of questions? So first, like I know that you can find out this distance because it's a radius. I know you can find out this distance because it's a radius. So you know two sides, you know this side and you know this side, correct? Now what you have to do, can you find this distance between centers? Yes, you can do that. So suppose that you got all three sides, you can find out the area of triangle. How? Heron's formula. Okay, so but my suggestion is always check whether these two circles are orthogonal or not, because if it is orthogonal na, you need not to calculate so much things. It will become much more easier than like if I'll ask you to choose over like Heron's formula or half base height, you will always go for half base height, correct na? So it's better to check whether these two circles are orthogonal or not. So what I'll do, I'll go with G1. G1 is what? Coefficient of x by 2 minus 2 by 2. So it's minus 1. Now, okay, actually we have to find out the center. So if we will find out the center, it will become much more easier. Okay, and for center we will play with G1 and G2. So I'll go with center 1. So center 1 is what? You know that you have to divide coefficient of x by 2, then multiply by minus. So it is 1, correct? And then coefficient of y by 2, then minus. So it is 1. So you got center, correct? Also go with the radius. You know it is g square plus f square minus of minus 2 c, है ना? So it will become 2. So you got center, you got radius. Now go with center 2. So coefficient of x divided by 2, so minus 3, then multiply by minus. So it is 3. Coefficient of y divided by 2 minus 3, then multiply by minus. So this is the center. Now go with radius 2. So 9 g square plus f square minus c. So c is 14. So again 18 minus 4 is 14 is 4. So radius is 2. Okay. So I'll go with the condition 2 g1 g2 plus 2 f1 f2 equals c1 plus c2, whether it is satisfying or not. So I'll go with LHS first. So 2 g is minus of 1 g1, g2 is minus of 3, because you know that the center is minus g minus f, but we are interested in g, so it will become minus of that. Okay, plus 2 times f1 minus 1 minus 3, है ना? Now I'll write c1 and c2. So who is c1? c1 is minus 2, c2 is plus 14. Now simplify. It is what? 6 plus 6 is equal to 12. Yes, LHS and RHS are equal. This means both circles are orthogonal. So if it is orthogonal, it is 90 degree. You know it is 2, it is 2, it is 2, it is 2. So area will be like, can I write area of quadrilateral PC1 QC2 is equal to 2 times area triangle PC1 C2. So 2 times half base height. So it is 4 square unit. Okay, and if it is not orthogonal na, then you will get some side length. Suppose it is some number, so you should apply Heron's formula. Do you remember Heron's formula? It was root over s minus a, s minus b, and then s minus c. You know s is semi perimeter and a, b, c are the sides. I hope idea is clear now. You can handle these kind of questions from now onwards.